Good evening, sir.
Ma'am, good evening, ma'am.
You can continue, sir.
Yes, ma'am.
Good evening, sir.
Where were you last two classes? Why you didn't attend last two classes?
Sir, I was there, sir.
Where?
Sir, I was attending, sir, using my, using
what?
Sir, using my mom's this thing, sir. I joined as under the post account.
You cannot lie.
Sir, no, sir, really, sir.
Okay, what topic we did last class?
Sir, you finished with the sums, sir.
No, that you can get it on YouTube also. You can view it on YouTube. Anybody can watch it on YouTube. That's a different story. How many sums I worked?
Sir.
How many sums I worked? Huh?
Sir, he joined, sir, really.
No.
Yeah, he joined in my name. Actually, I joined and then I left and went. He joined in my name. He continued in my name.
No. You cannot support people like this, because I can understand whether people are there in the class or not. He never even responded even a one single question, and you're also supporting Ajay. What to do, man? Huh? Ajay?
Sir, I was there, sir.
Okay. We'll continue.
Sir, since it was my mom's account, I didn't really want to answer, sir.
You are a liar, that I can tell you.
Sir, no, sir, really, sir. You can ask us, sir. I was there, sir. Last class, I was there, sir.
How early I finished the last class?
I didn't attend, sir, but for chemistry, I was there, sir.
Okay, tell me how early I finished the class last.
Sir, last time you finished around 7:57, 7:58, sir.
Regularly I do that.
Sir, no, sir. Last time you finished. Sir, last time you finished a bit later than usual.
No, that you weren't there.
Sir, yes, sir. Yes, sir.
Okay, anyway, we'll continue. We'll continue. All right, practice the other questions. Today, Dhanalakshmi is not joined yet. Right, I see Vaishnavi. Good. Anyways, the last part of the topic in electrochemistry, maybe another 2 classes I will require to work some of the numericals of the chapter. We have done maximum possible. Last part of the topic, we have batteries and we have fuel cells. We will learn batteries and fuel cells, and then we will try to sum up later. Now, what are batteries? Now, what do you mean by a galvanic cell? A galvanic cell is a cell which converts chemical energy into electrical energy. So any cell which converts chemical energy into electrical energy is called as a galvanic cell. Now we are talking about something called as batteries. Now what are these batteries? Batteries are galvanic cell where the chemical energy of the redox reaction is converted to electrical energy. So basically battery is made up of galvanic cells. So any galvanic cell will have 2 electrodes. You will have anode and you will have cathode. So a galvanic cell is an electrochemical cell which converts chemical energy into electrical energy. Likewise, a battery is also a galvanic cell made of more than one. So meaning, in physics, they talk about series connection and parallel connection. You would have heard of it. So many number of galvanic cells, when you connect it in series, then the total output of the voltage will be more. Those kind of galvanic cells are called as batteries. Now, what are batteries? Batteries are basically galvanic cells which are connected in series, in which the chemical energy is converted into electrical energy. Now, we have 3 types of batteries. And here we have mentioned only 2 for PUC level. One is called as primary battery. The other one is called as secondary battery. The third will be called as reserve battery. It's called as reserve batteries. So we have 3 types of batteries. One is primary battery, the other one is secondary battery. The third is reserve battery. We will talk about reserve battery a little later. Now in your syllabus, you have only primary and secondary batteries. Now what is this primary and secondary batteries? A battery, when you use, When it gets drained out, it cannot be recharged. It cannot be made reusable again. Those kind of batteries are called as a primary battery. Now, for an example, we have dry cell. In the market, you get dry cells for 15 rupees. Now, Eveready, Nip, and so many other companies are there selling batteries, dry batteries. Eveready, everybody would be knowing. So 15 rupees. That Eveready battery, when you use it, once it is completely discharged, you cannot reuse it again. You cannot recharge it again. Those kind of batteries are called as primary battery. A battery which becomes dead after the usage, after the discharge, is called as primary battery. So primary batteries are non-rechargeable batteries, or non-rechargeable cells, or non-reusable cells. Example, dry cell, mercury cell, now used in transistor, clocks, hearing aids, watches. Now you can, with the battery, what you're using in your watch, once the battery get used up, drained, you have to replace it with a new battery. You cannot recharge the battery. So those kind of batteries are called as primary battery. What do you mean by primary battery? Battery which cannot be recharged, battery which cannot be reused is called as a primary battery. A battery becomes dead once it is completely discharged. Those kind of batteries are called as primary battery. Now, when we talk about a secondary battery, example for a secondary battery is a lithium ion battery. Lithium ion battery is an example for secondary battery. These lithium ion batteries are used in mobile phones. So everybody is using mobile phone. That's why I've taken this as an example. Not lithium battery, it is lithium ion battery. Lithium battery is a primary battery. Lithium battery is a primary battery. Lithium ion battery is a secondary battery. What do you mean by secondary battery? When you are using a mobile phone for a long time, once the charge is minimum, what do? You plug it in and you're recharging it. So then you can use the phone again. So those kind of batteries are called as a secondary battery. Rechargeable batteries, rechargeable cells, or reusable cells are called as a secondary battery. Now, for an example, I will talk about this. Now, what I want you to understand is we spoke about something called as Daniel cell long back. Daniel cell. In order to construct a Daniel cell, we need to have a zinc electrode. We need to have zinc electrode, and we need to have copper electrode. Copper electrode. You know what is zinc electrode, copper electrode, all that. These electrodes are connected through an external wire through voltmeter, and they are connected internally by means of salt bridge. This is what we learned. Yes or no? Students, are you there?
Yes, sir.
Yes. Now you tell me the electrode which is placed on the left-hand side is called as what? It's called as anode. The electrode which is placed on the right-hand side will be called as cathode. The anode is represented by negative sign and cathode is represented by positive. Anode is a positive electrode represented by negative sign. Why? At anode, what takes place? At anode, oxidation takes place. At cathode, reduction takes place. Now, at anode, when you say oxidation, it is loss of electron. Zinc will undergo loss in electron to form Zn2 plus, giving it 2 electron. These electrons move in the external circuit towards cathode, where copper ions present at cathode will accept these 2 electrons and get reduced to copper. Now, on adding, what happens? You get Zn plus, Cu2 plus. These 2 electrons will get cancelled, gives you Zn2 plus and Cu. This is the overall reaction for Daniel cell. This is the overall reaction for Daniel cell. Now, this is the overall reaction for Daniel cell when the cell is in use, when the cell is discharging the current, when the cell is discharging. Now, we are talking about reversible battery. Assume this Daniel cell is the reversible battery. Now, once the cell is completely discharged, if you have to recharge it, this reactions will become what? Opposite. What do you mean by opposite? This becomes an anodic reaction. This becomes an anodic reaction, and this becomes a cathodic reaction. That means in any electrochemical cell, the reaction during discharge and the reaction during a recharge will be opposite. Are you following what I'm trying to tell? Now, in a mobile battery, the reaction which is taking place while you are using mobile phone, the chemical reaction is different. And while you're putting it for recharge again, the chemical reaction is what? Opposite of that. Are you following?
Yes, sir.
Yes. Now, secondary batteries or rechargeable batteries, reusable batteries, lead storage battery. What is this lead storage battery? Car batteries. Car batteries are called as lead storage battery. Nickel cadmium cells uses. It is used in automobiles, inverters, etc. Lithium-ion batteries used in mobile phones. These all are secondary battery. Now, reserve battery, when we talk about this reserve battery is used in case of rocket launching, all those, this reserve battery, in reserve battery, the electrolyte will not be in the system. That means electrolyte will be placed outside the connection, outside the system. Whenever is required, then the electrolyte is added and used. It provides high potential. Therefore, electrolyte is kept outside. That's the disadvantage of reserve battery. Anyways, we are not talking about reserve batteries in your PUC level. Anyways, now we have learned what is primary, secondary battery. Primary batteries are non-rechargeable batteries. A battery which becomes dead after discharge is called as primary battery. Example for primary battery is dry cell. This dry cell is also called as Leclanché cell. It's also called as Leclanché cell. See, this is there for your exam. Regular PUC, it is a 3-marker question, or they can ask you for 4-mark also. Now this dry cell or Leclanché cell. Now, in case of what the dry cell or the Leclanché cell, the container which is made of zinc is behaving like an anode. Container will behave like anode. So container is made of what? Zinc. And a graphite rod is placed at the center. This graphite rod behaves like a cathode. This graphite rod, which is placed at the center, is surrounded by manganese dioxide and carbon. Manganese dioxide and carbon. And also it will contain some amount of ammonium chloride, and it will contain zinc chloride also. We will learn the functions of all this. Now, this is the construction of a dry cell. What is this dry cell? A zinc container is anode, and a graphite rod, which is placed at the center, will behave like a cathode. And around this cathode, a paste of manganese dioxide and carbon, along with little amount of ammonium chloride and zinc chloride. See, graphite, manganese dioxide and carbon is surrounded around graphite rod. And the electrolyte here is ammonium chloride and zinc chloride, which is placed between cathode and anode. So ammonium chloride and zinc chloride will be placed between anode and cathode. So cathode is graphite rod surrounded by manganese dioxide and carbon. Anode is zinc, and the separation between anode and cathode is electrolyte, that is ammonium chloride and zinc chloride. No problem with the construction? Do you understand the construction part of it?
Yes, sir.
Everybody? Others? All right. Now, what is the cell reaction? We know this reaction at anode, oxidation takes place. Anode is a zinc. So oxidation takes place. What is oxidation? Loss of electrons is called as oxidation. So zinc loses 2 electrons to form Zn2 plus. Now this electrons, which is given by the anode, has to move towards cathode. When I say it's moving towards cathode, you see at cathode what happens? Manganese dioxide. In manganese dioxide, manganese ion has +4 charge. This manganese having +4 charge, in the presence of ammonium chloride electrolyte, it accepts an electron, then it forms a compound like MnOOH. This is, in a case of MnOOH, manganese will have +3 oxidation state. Oxygen is -2, hydroxyl ion is -1. So manganese will have +3 oxidation state. That means manganese dioxide is getting reduced to MnOOH. See here, the theory, manganese is reduced from +4 oxidation state to +3 oxidation state. And ammonia is produced in the reaction and forms a complex with zinc ion. So this zinc ions will react with this ammonia and it forms a complex. This complex, we will learn about it a little later. There's a chapter called as coordination chemistry, in which we have to learn more more detail about these complexes. Now, what is the potential produced by this cell? The potential produced by this cell is 1.5 volts, and it is used in transistors and clocks. See, these reactions has to be balanced, and this reaction has to be memorized. Okay, it's a very simple explanation. Did you understand this? Now, zinc is made as an anode. At the center, at the container, the center, a graphite rod surrounded by manganese dioxide and carbon, fine powdered carbon, and electrolyte like ammonium chloride and zinc chloride is placed between anode and cathode. So what happens at anode? The zinc will undergo oxidation to Zn2 plus 2 electrons, and cathode reduction. This manganese dioxide will undergo reduction to MnOOH, giving you ammonia gas. This ammonia gas which is formed reacts with this Zn2 plus to form a complex. What happens? Now, loss of electrons at anode and gain of electrons at cathode is nothing but change in chemical reaction. This change in chemical reaction appears like a current. That is why it produces 1.5 volt. Understood this dry cell? Students, did you follow?
Yes, sir.
Others also can participate and tell. I'll be happy if you could tell yes, at least. All right. The next what we have is called as a mercury cell. This mercury cell is also a primary battery. Mercury cell is also a primary battery. What do you mean by a primary battery? A non-rechargeable battery will be called as primary battery. Now, zinc and mercury amalgam. Mercury is a liquid metal in which all other metal can be dissolved. So zinc in mercury will be called as zinc amalgam, or it is called as zinc mercury amalgam. Zinc is again a cathode. Zinc and mercury is again a cathode. Now, cathode is a paste of mercuric oxide and carbon. It's a paste of mercuric oxide and carbon. Electrolyte is potassium hydroxide. Potassium hydroxide is a base. Since potassium hydroxide is a base, mercury cell is an example for alkaline battery. So when the electrolyte is a base, when the electrolyte is an alkali, then the battery will be called as alkaline battery. So mercury cell is an example for an alkaline battery. So at anode, we have zinc and mercury, zinc mercury amalgam. At cathode, you have mercuric oxide and carbon. And the electrolyte here is potassium hydroxide and zinc oxide. Now, what should happen? See, this is an alkali. This potassium hydroxide will dissociate to form K plus and OH minus. So OH minus ions are present here, remember. So at anode, oxidation has to take place. When I say at anode oxidation, anode is zinc here, zinc and mercury, zinc mercury amalgam here. So what happens is this zinc mercury will lose 2 electrons to form zinc oxide and water. Now here the charge on zinc is 0. Here the charge on zinc is +2. So loss of electron is called as oxidation. This reaction is complex, you have to memorize. Now at cathode, these electrons will move towards a cathode. When we say this 2 electrons move towards cathode, at cathode what we have? Mercuric oxide we have. At cathode, gain of electrons, reduction will take place. So this mercuric oxide, which has a +2 charge in aqueous medium, in the presence of water, accepts 2 electrons and becomes neutral mercury. The charge on mercury is 0 here. From +2 to 0, there's a decrease in charge. Therefore, it's called as reduction. Here it is oxidation, and here it is reduction. So in any electrochemical cell, the reaction is a redox reaction. So when you add these 2 equations, you will get zinc mercury amalgam plus HGO solids, mercuric oxide, giving you zinc oxide and mercury. These two electrons will get cancelled. This water will get cancelled. So the potential given by this mercury cell is 1.35 volt. Followed. This is complex and you need to require a lot of practice. Reaction. Do you understand this? Any doubts you can ask me. Students, please interact with me and ask. No doubts?
No, sir.
All right. The next one is very important. This is dry cell is important. And this, what we are learning, is very important. That is lead storage battery. This is also called as car batteries in general. And this is acid battery. It's an example for acid battery. Because acidic battery or acid battery. Okay. Now, because the electrolyte will be an acid here, therefore, it will be called as an acid battery. And example is car battery. Most of you people would have seen car battery. Anyways, now anode is lead. Anode is lead. Completely. It is made of lead. Lead is PV. And cathode is a grid or maybe a container packed with lead as well as lead dioxide. So this is cathode. Anode is a pure lead. Anode is pure lead. Cathode is a mixture of lead and lead dioxide. Very important. Please participate in the class. Right? Anode is pure lead. Cathode is lead as well as lead dioxide. It's a mixture of lead and lead dioxide. You can see here they say grid of lead packed with lead dioxide. Grid means you have seen wire gauze or mosquito nets you have seen at home, or wire gauze in the chemistry lab. So this is like a grid. In this grid, you will have what? Lead as well as you will have what? Lead dioxide packed. All right. For our understanding. Now, these cathode and anode is immersed in an electrolyte. When we say the immersed in an electrolyte, it is immersed in 38% sulfuric acid. 38% sulfuric acid. Now, these are connected to the power supply. This is the construction of lead acid battery. It's also called as lead acid battery. Lead acid battery or lead storage battery or lead acid battery. It's all the same. Example for acidic battery, they ask you lead acid battery. You should be in a position to answer. Now, did you understand the construction? Anode is purely lead. Cathode is lead, mixture of lead and lead dioxide. And the electrolyte here is acid. What's the concentration of the acid? The concentration of the acid is 38% acid, sulfuric acid. Followed? Yes or no?
Yes, sir.
Yeah. The sulfuric acid will dissociate to give hydrogen ion and sulfate ion. That means in this solution, you have H plus ions as well as you have SO4 2 minus ions. Remember that. Now at anode, what should take place? Oxidation has to take place. What do you mean by oxidation? Loss of electrons is called as oxidation. Now lead reacts with the sulfate ions. So to form lead sulfate, see here, this firstly what happens is lead will lose 2 electrons to form lead ions, Pb2 plus ions. This Pb2 plus ions will react with sulfate to form lead sulfate. So when you add these two equations, what happens is you'll get this overall equation. So directly we have written lead reacts with sulfate ion to form lead sulfate, giving you 2 electrons. Therefore, this reaction is called as oxidation. See, sulfate ions, you get it from sulfuric acid. So lead anode is reacting with sulfate ions to form lead sulfate, giving you 2 electrons. These electrons will move towards cathode. When I say these electrons will move towards cathode, at cathode we have lead dioxide. In this lead dioxide, the oxidation state of lead is +4. The oxidation state of lead is +4. Now this lead dioxide reacts with sulfuric acid. That is SO4 2 minus and H plus sulfuric acid. Why I've taken 4 H pluses? Because in lead dioxide, we have 2 oxygen. These 2 oxygen will react with 4 hydrogen ion to form 2 moles of water. What else is left out? When oxygen and hydrogen is reacted, what else is left out? Pb plus SO4 2 minus gives you PbSO4. Same thing, PbSO4. When you add these 2 equations, what you get? Pb, which is a solid, plus PbO2, which is a solid. And you can see sulfuric acid, SO4, 2 SO4 and 4 H plus. Therefore, 2 moles of sulfuric acid, giving you 2 PbSO4 plus 2 moles of water. Did you understand the overall reaction? This is the reaction which takes place during discharge. Discharge, when we are using the car battery. Now, this car battery is a secondary battery. When I say car battery is a secondary battery, it's a rechargeable battery. When you recharge, what happens? The reaction is reversed. On charging the battery, the reaction is reversed. And PbSO4 on anode and cathode is converted to Pb and PbO2 respectively. The reaction becomes what? Reversible. It is a very important question. If you have any clarification, you can ask me quickly. Hello, any questions? Ajay,
No,
Ritika,
sir. No, sir.
Vaishnavi, you understood this?
No, sir.
Ritika and Vaishnavi? Yeah. Right.
Understood.
You understood. Very good. Very good. Now, the next part of the topic. See, this is very important. Again, I'm telling you, this dry cell, lead storage battery, chemical reactions you need to write. Completely balanced reaction only, you will get full marks. So if the reaction is not balanced, you cannot claim for the marks. Remember, in chemistry, that balancing the equation becomes tough. That is why many students lose marks in chemistry. Even though they know the subject, they don't write the balanced equations. So balanced equation is important. The next is a nickel cadmium battery. This nickel cadmium battery, this cell is having more life than lead storage battery. But due to its more expensive in cost, usage of this cell is less. Nickel and cadmium, they're all heavy metals, all right? And it's costly metals. Therefore, they're not used. That's what the clear statement says. So in nickel cadmium battery, cadmium, here the charge is 0. Cadmium is anode. This cadmium gets oxidized to cadmium oxide. And nickel is cathode. You can see +3 here. Here the nickel is getting reduced to +2. So nickel will undergo reduction. So nickel will be cathode here. So it's a simple reaction. Nickel and nickel hydroxide, nickel trioxide here. This is trioxide. And cadmium reacts with nickel trioxide to give cadmium oxide and nickel dioxide. So this is with respect to the nickel cadmium battery. We will learn the nickel cadmium battery in detail. Before that, maybe I'll just give you anode is cadmium. Anode is cadmium. And cathode is nickel dioxide. Cadmium and cathode is nickel dioxide, NiO2. And the electrolyte here in this is potassium hydroxide. Therefore, this is also an example for alkaline battery, because the electrolyte what we're using is nickel. There is a question wherein I have to teach you the chemical reaction. We will learn the chemical reaction in a few minutes time based on this nickel cadmium cell. All right, so nickel cadmium cell is also an example for alkaline battery. Some of the questions we will learn based on batteries, and then we'll go for fuel cells. Now, the first question here is a button cell used in watches. The cell what we use in watches is called as button cell. Functions as follows: zinc plus Ag2O solid plus water in liquid state. It's a double-headed arrow, gives you silver plus Zn2 plus aqueous and plus 2 OH minus aqueous. If the half cell potential are, for zinc, the half cell potential is minus 0.76 volt, and for silver, which is undergoing reduction, the electrode potential is 0.34 volt. 0.34, the cell potential they're asking. So anode is zinc because zinc is undergoing oxidation. Here silver has +1 charge. Here silver has 0 charge. Since it gains electrons, it's called as reduction. So cathode is silver oxide. It's undergoing reduction. Now, what is the EMF of the cell they're asking, or the cell potential of the cell? Cell potential will be. So E cell will be equal to electrode potential of cathode minus electrode, or EMF, put electrode potential of cathode minus electrode potential of anode. Last class, if you remember, I told you, how do you identify which is undergoing oxidation and reduction? How do you identify which is cathode and anode? So the electrode with higher potential will be cathode. The electrode with lower potential will be anode. See, this is plus 0.34. Then it is minus 0.76. This trick you should remember. Cathode is having higher potential and anode will have lower potential. So therefore, it will be electrode potential of Ag2O minus E0 of zinc. So that will be plus 0.34 minus of minus 0.76. So it will be 1.1 volt. The answer for this question is option A, 1.10 volt. Did you follow this?
Yes, sir.
Now you tell me which is anode and cathode here. For aluminum electrode, the potential is minus 1.66 volt. And for zinc electrode, the electrode potential is minus 0.76 volt. Amongst this, which is anode and which is cathode?
So
Which
it's
is large?
aluminum.
Aluminium?
So aluminum's anode, sir. Zinc cathode, sir.
Okay. Now you tell me which is larger here? 0, minus 1, minus 2, minus 3. Which is larger amongst this?
Sir, sir, opposite way around, sir. Then.
Now you tell me which is
0.
larger here. So minus
Sir,
1 is
minus
larger,
1
no?
is larger, sir. Yes, sir.
Then this negative
Yes, sir.
one.
So it's the
this
other
will
way
be-
around, sir. Yes, sir.
Yeah. So larger, this will behave like cathode and this will behave like anode. Remember that. All right. So both are negative potential. You should be in a position to justify which is anode and cathode. Larger the potential cathode, lesser the potential anode. Okay. When a lead storage battery is discharged, lead sulfate is consumed, oxygen is evolved, lead sulfate is formed, lead sulfide is formed. So in the lead storage battery, we learned the reaction. Again, I'll write the overall reaction. Lead and lead dioxide. This is anode, this is cathode. Overall reaction I'm writing in water, aqueous medium, gives you 2 moles of lead sulfate and 2 moles of water. This is the overall reaction. You can see the overall reaction here. Yeah, this is the overall reaction. Same thing I wrote here. You should write the physical states of the components also, otherwise you will lose marks. So this is the overall reaction. What is formed here? As per the question, when a lead storage battery is discharged, what is formed? This is during discharge, and this will be during recharge. During discharge, what is formed? Lead sulfate is formed. During recharge, what is formed? Lead and lead dioxide is formed. Remember. So the answer for this question will be option C. Followed? Yeah. Okay. No response means I have to just move around. That's all. Are you there?
Following, sir.
Very good. Now the next question, the reaction which is taking place in nickel cadmium battery can be represented by the following equation. They have given the chemical reactions. They are asking the overall reaction in nickel cadmium battery. Nickel cadmium battery is an example for alkaline battery. Nickel cadmium battery is an example for alkaline battery. What is the anode here? In case of nickel cadmium battery, what is anode? Anode is nickel. Anode is cathode, sorry. Anode is cathode. Was it cadmium, sorry. And what is cathode here? The cathode here is nickel dioxide. Nickel dioxide. And what's the electrolyte? I told you the electrolyte is potassium hydroxide, KOH, potassium hydroxide. At anode, what should take place? Oxidation has to take place. Since we have potassium hydroxide, you will have K plus and OH minus. So what happens is cadmium will lose 2 electrons to form cadmium 2 plus. This cadmium 2 plus will react with OH minus of potassium hydroxide to give cadmium hydroxide. So this is the overall reaction at cathode. What happens now? Overall reaction will be cadmium plus 2 OH minus giving you cadmium hydroxide. This is the reaction at anode, overall reaction at anode. Excuse me. What will be the reaction at cathode? At cathode, we have nickel dioxide. Here, the charge on nickel is plus 4. This nickel dioxide will accept electrons in the presence of water. These electrons which are given out at anode will be gained by nickel. So you will get nickel hydroxide and you will get 2 OH minus. So here the charge on nickel is plus 2. Gain of electron is called as reduction. So what happens when you add these two equations, anode and cathode? If you add, what happens? Cadmium plus NiO2 plus 2H2O giving you CdOH2 as cadmium hydroxide, plus what you will get? You will get nickel hydroxide. These all are solids. Nickel hydroxide, cadmium hydroxide is solid. Water is liquid, remember. So this is the overall reaction. So what will be the answer for this question? The answer for this question is option A. This is the reaction which takes place in nickel cadmium cell. So I didn't teach you the reaction because there's a reaction in question to be learned. So I did it now. Clarify if you have any doubts quickly. Following?
Yes, sir.
Yeah. See, if you think that I'm teaching a little faster, it's okay. It's available in the YouTube all the time. You have to prepare notes by yourself. You have to start writing in a notebook. Just listening to a topic or just watching a topic, it's not going to give you any kind of benefits. So you have to start writing in a notebook. Only when you write, it will register in your mind and you can reproduce it during your exams. So write and practice. Read loudly, write and practice. That's how you learn any subject. Now, anyways, the next is fuel cells. What is this fuel cell? What happens when you burn wood? When you burn wood, what do you get? When you burn wood, what do you get? When you burn wood, what do you get? Simple.
Sir, ash, sir.
Ash you get, fine. That's fine. The product is ash and all that is fine. Okay, carbon dioxide, water, ash, all that is fine. What else you get? What else you get?
Sir,
You get heat energy.
yes, sir.
So when you burn a wood, you get heat energy. Heat. So wood is also an example for a fuel, remember. Now the same, if you take any material in material X, and if you burn, and if you get electrical energy, then those kind of cells are called as fuel cells. Instead of giving you what energy? Heat energy. If you burn any fuel, if it gives you electrical energy, then those kind of cells are called as what cells? Fuel cells. Did you understand the definition of a fuel cell now? So fuel cell, these are voltaic cell in which the reactants are continuously supplied to the electrode, and they're designed to convert the energy from the combustion of fuels directly into electrical energy. So when you burn something is called as combustion. When you burn a fuel, if you get electrical energy, then we call that as what? Fuel cells. Then we call that as what? Fuel cells. Now, the disadvantage of fuel cells is the reactant has to be continuously supplied. Now, for an example, we have hydrogen oxygen fuel cell. Hydrogen is a fuel, oxygen is oxidizer. Now, oxygen has to be stored in a separate tank, hydrogen has to be stored in a separate tank. These has to be continuously supplied. Only then what happens? This fuel can be burned and the energy can be directly converted into what? Electrical energy. Then we can call that as a fuel cell. Example for fuel cell is hydrogen oxygen fuel cell. Now, what is a fuel cell? A cell, a voltaic cell in which the fuel is burned in order to when the fuel is burned, electrical energy is given. See it clearly. These are designed to convert energy from combustion of the fuels like hydrogen, carbon monoxide, methane, etc., directly into what? Electrical energy. If you burn wood, you get heat energy. But if you convert energy of the combustion into electrical energy directly, then we call that as a fuel cell. Now, we have fuel cells, 3 types of fuel cells. Low temperature fuel cells, moderate temperature fuel cells, high temperature fuel cells. That is in higher level you will be learning if you take up engineering. Otherwise, you will not learn. Now, in our syllabus, we have only hydrogen oxygen fuel cell. We have hydrogen oxygen fuel cell. Now, you have 2 platinum electrodes. You have 2 platinum electrodes, or you can have graphite electrode. I don't know whether I've taken the picture. Anyway, yeah, it's here, you can see. Right? 2 platinum electrodes, or it can be porous graphite. You can take platinum, rhodium electrode also, or carbon electrodes, graphite electrode. These are 2 electrodes. Both are porous carbon electrodes. These 2 are electrodes. At one of the electrode, hydrogen is supplied, continuous supply, anode. Anode is a positive electrode represented by negative sign. At cathode is again a carbon electrode, oxygen is supplied continuously. And the electrolyte is potassium hydroxide. In potassium hydroxide, the hydroxyl ion they are represented. Followed the construction of the fuel cell, it's important. Only one fuel cell is there in your syllabus, it's important. That is hydrogen oxygen fuel cell. Did you understand the construction? You have 2 porous carbon electrodes. At one of the porous carbon electrode, hydrogen is passed. It acts as anode, and at cathode, oxygen is passed, and you have electrolyte at the bottom, and you can see an arrow mark, and I wrote it water. The steam or the water vapors gets eliminated. Now, what's the construction part of it? In the cell, hydrogen and oxygen are bubbled through porous carbon electrode into concentrated sodium hydroxide or potassium hydroxide. Here, hydrogen is acting as a fuel. Fuel is fed at anode compartment where it is oxidized. The oxygen is fed at cathode compartment where oxygen is reduced. The diffusion rate of the gases into the cell are carefully regulated to maximum efficiency. The net reaction is very simple. Don't worry about this statement. The diffusion of gases and efficiency you do not have in the syllabus. Don't worry about this statement. All right. Now, what you should know is hydrogen is passed at anode, oxygen is passed at cathode. Anode and cathode both are porous carbon. And the electrolyte here is potassium hydroxide. At anode, what happens? Hydrogen gas, which you're passing, the charge on hydrogen is 0. This hydrogen gas reacts with the OH minus ions of potassium hydroxide. The electrolyte here, they represented as potassium, that minus, and it gets converted to water. So the charge on hydrogen is 0 here, the charge on hydrogen is 1. So hydrogen gas is oxidized to water, giving 2 electrons. These electrons move at cathode. The charge on oxygen here is 0. In the presence of water, it accepts 4 electrons and it gets reduced to OH minus. Gain of electron is called as reduction. Oxygen is O2. Water is 2 moles they have taken, 2 H2O. Therefore, you get 4 OH minus. So when you add these 2 equations, You get 2H2 plus O2, giving you 2H2O. This is the overall reaction. It is nothing but combustion of hydrogen gas. When hydrogen gas is burnt, you get water. But what happens? Instead of giving heat energy, it is getting converted into electrical energy. Therefore, it's called as a fuel cell. Compressed carbon containing small amount of catalyst, platinum, silver, or cobalt oxide. This is a catalyst. So this is carbon electrode. So you will have few amount of what? Platinum or silver or cobalt oxide, which acts as a catalyst. The cell runs continuously as long as the fuel is fed, as long as the reactant is fed. If you don't supply reactants, then the fuel cell will not work. The fuel cell converts energy of the fuel directly into electricity. And this hydrogen oxygen fuel cell, the potential produces 1.3 volt. This cell has been used for electric power in Apollo space program. The important advantages of fuel cells are, these all are the properties which you don't worry about it. It's not there for your POC syllabus. Competitive exam, if you want, you can go through. One or two questions about the fuel cells, and then we're going to stop. One more class I require on this chapter. In one more chapter, I will write some of the questions and explain. Now, a device that converts energy of combustion of fuels like hydrogen, methane directly into electrical energy is known as, it's a direct question, it is fuel cell. Answer is fuel cell. The efficiency of fuel cell is given by efficiency of the fuel cell is represented by letter phi, and that is delta G versus delta H into 100. Delta G is free energy change, delta H is enthalpy. So this is the formula to calculate the efficiency. So efficiency is expected to be 100% for a good fuel cell. The answer for this question is option B. All right. So this is electrode potential. Nernst equation we have learned, derivation, all that 4 types, oxidation potential, all this is not there for you. We have learned all this, EMF, all that. All right. So any clarification with the batteries and fuel cells quickly? Any questions, students, quickly?
No, sir.
No, sir. Completely followed or nothing followed?
So followed, sir.
What will be your score in your exam?
Sir, full, sir.
You cannot lie to me again and again.
Sir, no, sir. Really, sir.
I would like to meet you sometime.
Sure, sir.
Where shall I come and meet you?
Sir, come to our house, sir.
I'll come to your college and meet Sundaram, sir, and tell him that he's not attending regularly and is lying to me saying that he attends the class. I'll tell him. All right.
Sir.
All right. All right. Now, types of electrode potential. 2 minutes, I'm finishing the class. Types of electrode potential. Depending on the nature of the metal electrode, to lose or gain electrons, the electrode potential may be of 2 types. One is oxidation potential. When the electrode is negatively charged with respect to the solution, that is, it acts as anode, oxidation occurs. So whenever the metal is undergoing oxidation, that time the potential observed will be called as oxidation potential. Now, coming to the reduction potential, when the electrode is positively charged, what do you mean by electrode is negatively charged here? Now, this is an electrode. Assume that it to be zinc. The zinc undergoes oxidation to form Zn2 plus 2 electrons. These electrons will be accumulating here. This electrode becomes negatively charged now. That time the potential, what you measure, is called oxidation potential. But the electrode, when the electrode is positively charged with respect to the solution, it acts as cathode. So reduction occurs. So if this is copper and you have copper ions here, these copper ions will accept 2 electrons to form Cu2, Cu copper. So this means this copper ions will be accumulating here, positively charged. Therefore, this electrode becomes positively charged. And the potential measured is called as reduction potential. So oxidation potential, reduction potential you have. So reference electrodes, we learned. Hydrogen electrode, I taught you. Reference electrode, calomel electrode, all that I taught. All right. So anyways, cell potential, EMF also we learned. E cell is given by the formula E cathode minus E anode. So one more class, maybe on Tuesday, we'll finish off with this chapter, electrochemistry, and go to the fourth chapter, kinetics, possibly. All right. Any clarifications quickly, students?
No, sir.
Okay, ma'am, I'm stopping the class, ma'am. Ma'am, stopping the class. Hello.
Yes, sir. Thank you, sir.
Yeah, ma'am.